Okay, so hello everyone, welcoming you to Shourab's classes. And today we are looking at the IIFT MC Economics Entrance 2019 paper, question number 5. Using the ISLM model, show the effect on output and interest rate of a decrease in government spending. Can you tell what happens to investment and why? Describe the effect of decrease in government spending in words. Okay, so we need to use the ISLM diagram for this part. So, what is happening basically? Part A. So, this is a question from the ISLM model, and we need to evaluate the effects of a fall in government expenditure. So, that is DG negative. So, if we look at the diagram directly, so taking the standard ISLM framework without much of an hassle. So R on the vertical axis, Y on the horizontal axis, negatively sloped IS initially, positively sloped LM. So this is your LM and this is your IS. Okay, so the equilibrium point is right here. So this is your optimal interest rate and this is the Y. This is the equilibrium. So now what happens? A fall in G means the IS curve shifts downwards with the LM curve staying put. So this is what happens. So this is basically you have the new IS dash corresponding to fall in G. So this is the new equilibrium G dash. So what happens? The interest rate falls, the optimal interest rate falls, and the optimal output also falls. So R falls to R double star and Y falls to Y double star. This is what basically happens diagrammatically that you can see. Okay. So now let us have a look at the reasoning of why this is happening. So if you recollect the standard equations of the ISLM curve, so what does the IS curve look like? It basically represents the goods market equilibrium. So C, which is a function of Y, I, which is a function of R plus G, right? And what is the LM curve looking like? It is the real money balance M bar by P is L as a function of YR. And let me just write down the signs of derivatives as well. Ly positive, Lr negative. And over here on top of your I prime is negative and C prime lies between 0 and 1. Okay. So now let us understand what is happening. So we want to evaluate the effect of a fall in G over here. So when G falls, what happens? G falls means the aggregate demand falls. So given a demand determined structure, aggregate demand falls means Y falls that you can see. So given a Y falls, this will imply that the transaction demand for money falls. Given the money market equilibrium, the money supply is fixed. So in order to balance that, fall in transaction demand for money implies the speculative demand for money should rise, and speculative demand for money should rise implies R should fall because of the negative interest rate. And that is exactly what you can see. A fall in G encompassing a fall in Y and a fall in R. So this is the reasoning. So you can write it in words, I guess. That will not be a problem. So that is what the answer should be. That we need to describe the effect of decrease in government expenditure in words. So you can just basically frame this reasoning out. It's a very simple reason that we are talking about. I think you can do that. Okay. So now coming to part B of the question. Now consider the following ISLM model, and we need to solve for the equilibrium output and the interest rate. and under what condition the parameters of the model, that is C0, C1 and so on, will the equilibrium investment increase with decrease in G. So let us compute the first two things directly and then we can go to this one. So part B of the question. Okay. So let us first construct the ISLM equation straight away. So what will the IS curve look like? It will be C0 plus C1 times y minus t plus just a moment, it's okay, autonomous investment plus b1y minus b2i plus g, right? So a little bit of calculation will be 1 minus c1 minus b1 times y plus b2i is equals to c0 minus c1 times t plus b0 plus g. This is the IS curve, equation 1. And what's the LM curve looking like? Is basically your, what are the notation once more? M by P equals to D1y minus D2i. So D1 times y minus D2 times I equals to M by P. So this is the LM curve. So this is equation 1 and this is equation 2. So we need to solve for the equilibrium output and the interest rate in the first two cases. So this can be done pretty easily. So we are not going to solve the entire equation, that can be done. So I'm just writing it out. So what will be y star? It will be basically the, you can do it by any rule. I'm using the Kramer's rule. Minus d2 whole divided by the determinant, the coefficient determinant. 1 minus c1 minus b1 b2 d1 minus d2, and I star will be over here, 1 minus c1 minus b1 c0 minus c1t plus b0 plus g. This will be d1 m by p and divide by the coefficient matrix. 1 minus c1 minus b1 b2 d1 minus d2. Okay, you can compute this out. This is not a problem. This can be done directly. What I am more interested in part C. We are basically told to find some condition on the parameters of the model so that the equilibrium investment will increase when G decreases. That means we are basically told to find out a condition such that del I star by del G is negative, right? As G decreases, investment should rise. That means the inverse relation. We need to find what condition on the parameters will ensure this kind of a scenario. Okay. So now carefully look at the investment function once more. So I is equals to B0 plus B1y minus B2i. Correct? So if you want to find out the optimal investment, you will just substitute the optimal output and optimal interest rate in this expression. Okay, fine. Okay, so this might involve very complicated expressions that you can see, because when you expand these two, it's going to look very complicated, but that's how the answer is demanded. And we are told to find out this thing, del I star by del G. So what will that be? It will be B1 times del Y star by del G minus B2 times del I star, sorry, not Y, del I star by del G. So we basically need to evaluate this expression, and for that we need the values of these things. del y star by del z, del I star by del z. Now we can expand this and get it, but we can get it much easily. So look at equation 1 and equation number 2. Just differentiate it totally. So that will give you 1 minus c1 minus b1 times dy plus b2 times di equals to, we are looking for a change in d. So that is dg. And equation number 2 states it's basically d1 times dy minus d2 times di is equals to 0. So from here we can easily compute what will be my dy and di, right? So what will be my dy over here? It will be basically dg 0 b2 minus d2 divided by the coefficient determinant, which is, okay, since we'll use it very often, let me just write it in short as determinant d without any confusion. So that will be minus d2 times dg divided by determinant d. And what will be my di over here? It will be basically your, this will remain 1 minus c1 minus b1 d1. Over here we will insert dg and 0 divide by determinant d. So that will be minus d1 dg divide by determinant d. So from the first expression, what do we get? Dy dg equals to minus d2 by determinant d, and from here we get di dg is equals to minus d1 by determinant d, where what is my determinant d? It's basically, just writing it once, 1 minus c1 minus b1 b2 d1 and minus d2. It's basically the coefficient determinant that we are writing. So after obtaining these two expressions, dy by dg and di by dg, what are we supposed to do? We'll just simply put this in this expression. Del I star by del g. So what was it? It was b1 times del y star by del g minus b2 times del I star by del g. So we are basically going to get del I star by del g is equals to b1 times its minus of d2 by determinant d minus b2 minus d1 by determinant d. That means del I star by del g is equals to your b2 d1 minus b1 d2 divided by determinant